Hello, my name is Aboutaleb-Kermani, and in this video I'm going to be telling you a little bit about Microbacterium leprae. So first I'm going to talk a little bit about the history and sort of the ecology of this pathogen. M. leprae causes leprosy, and it has existed in human populations since prehistoric times. As the graphic above shows, it existed in prehistoric Africa and then spread along human migration routes into Eurasia about 40,000 years ago. It also reached North and South America about 500 years ago. It was discovered in 1873 by Hansen. This is why it's called Hansen's disease. Since its discovery, many things have been used to treat leprosy, including chalmugra nut oil, promin, and dapsone. Dapsone has proven to be the most effective treatment. However, resistant strains arose in the 1960s, so we use combination treatments today. The animal reservoir in the United States is the armadillo, and the 9-banded armadillo is a common in vivo model for M. leprae. Next, I'm going to talk a little bit about the pathogen itself, specifically its secretion system, how it spreads, its shape, its properties, and how the host immune system and the pathogen interact to create symptoms of leprosy. M. leprae is a type of Mycobacterium. It is a rod-shaped bacteria, but it is a non-tuberculosis Mycobacterium. It is an acid-fast bacillus that is resistant to decolorization by acids. There's a high content of mycolic acid in the cell walls, resulting in a waxy appearance, as well as hydrophobicity and impermeability to routine staining, like gram staining. Thus, Ziehl-Neelsen staining, Cayenne staining, and fluorescence microscopy are often used to visualize this pathogen. It is an obligate intracellular pathogen, and it is an obligate aerobe, meaning it can only survive inside the cell, and it can only survive where oxygen is present. It survives best in cold temperatures, and it proliferates slowly. So it is most often observed in the skin, Schwann cells of the peripheral nerves, and the mucosa of the upper respiratory tract. Microbacterium leprae inhibits phagolysosomal fusion in order to survive in the cell and proliferate in macrophages. There are two types of leprosy based on the immune response to M. leprae that I will talk about a little bit later. This involves the type of T helper cells that respond to the pathogen. It is also a type 7 secretion system, but M. leprae, unlike M. tuberculosis, something else in the same genus, lacks the ESX2 secretion system as well as the ESX4 system. So as I mentioned earlier, M. leprae is able to proliferate within cells by inhibiting phagolysosomal fusion. M. leprae then proliferates within macrophages, and two different host immune responses can be activated. The first involves Th1, the first type of T helper cell. This results in tuberculoid leprosy through the secretion of IL-2 and interferon gamma. This results in the activation of cytotoxic T cells, natural killer cells, and macrophages. This is known as a cell-mediated response and is noted as high cell-mediated immune response. This results in a limited number of skin lesions and asymmetric nerve involvement. The other type of tuberculosis is Lepromatous tuberculosis, and it is the result of the activation of Th2 cells, or T helper cells 2. These result in the secretion of IL-4, 5, and 10 cytokines. This is a humoral response, and thus it is not effective in killing M. leprae. This type of tuberculosis results in differing symptoms. Thus, we can truly see that it is a combination of the pathogen itself and the host response to the pathogen that dictates the symptoms of disease. Lepromatous leprosy is known for having an extensive spread. It has poor cell-mediated immunity. It is the most severe of the two, and it involves a relatively high bacterial load. Tuberculoid leprosy, on the other hand, it has restricted pathogenic growth due to the activation of the cytotoxic T cells and natural killer cells. It has high cell-mediated immunity and is less severe than Lepromatous leprosy. It does not involve a high amount of bacterial load. So we've learned a little bit about the history behind M. leprae, its ecology, as well as what happens within cells infected with M. leprae. But what about its social context? M. leprae results in leprosy, which is a very visible disease. Leprosy can be disfiguring. For example, lepromatous symptoms include raised, poorly demarcated skin lesions. They can also result in the decrease or loss of sensation in the hands and feet, as well as loss of sensation in limbs. You could possibly have paresthesis or abnormal dermal sensations such as tingling or numbness. Lumps or swelling on the earlobes or face are common. This can result in leonine facies, hair loss, nasal septum destruction. There can also be loss of the fingers and toes due to necrosis. They may even fall off. Chronic uveitis has also been observed, as well as the inability to fully close the eyes due to facial nerve paralysis. Tuberculoid leprosy is less severe, but well-demarcated red patches, nerve involvement, some tenderness, some enlarged peripheral nerves, and some advanced symptoms such as claw fingers and foot drop have been observed. Due to these symptoms, there has been a historic separation of those suffering from leprosy from the general populace. For example, the Japanese law that required the isolation of leprosy patients was not abolished until 1996. Leprosy was often seen as death before death due to the extreme prejudice, fear, and revulsion around the disease. Leper colonies still exist today, and although leprosy has largely been eradicated in the U.S., one leper colony still exists in Hawaii. Leprosy can be seen in more than just history books. For example, it was even mentioned in the movie Ice Age: The Meltdown in 2006, with Sid the Sloth guessing leprosy as the L word that had afflicted Manny. Overall, leprosy is a very interesting disease caused by a very interesting pathogen. Although there is a cure for leprosy, there are many who go untreated and many who are afflicted by the disease. It is very much in need of attention and awareness. Leprosy Day does occur yearly, so make sure you mark it on your calendar. These were the sources used for this presentation. I will also provide a link to all of these sources in the description below. Thank you so much for watching the presentation. Have a great day.